Question 41, Electrical Engineering, GATE 2017, Set 2. For the network shown, the Thevenin equivalent voltage VAB is dash. 4 options are given to us to choose from. For a detailed lecture on Thevenin's voltage concept, please refer the Module 1, Lecture 10, Thevenin and Norton Theorem and Equivalent Circuits by Dr. Nagendra Krishnapura, IIT Madras. Let's see what Thevenin's theorem states and then solve this problem. The Thevenin's theorem states that it is possible to simplify any linear circuit to an equivalent circuit with just a single voltage source and a series resistance connected to a load. So, according to this theorem, any complicated network or any simple network of resistance can be simplified this way. It can be simplified as a Thevenin equivalent resistance which is connected in series to a voltage source which is VTH or the Thevenin's equivalent voltage. And to this terminals the load's resistance is connected. To find out RTH, we need to short circuit the voltage sources and we need to open circuit the current sources. And now when the voltage source is short circuited and current source is open circuited, then the effective resistance of the network with respect to the load's terminals becomes the Thevenin equivalent resistance RTH. The reason we are short circuiting voltage source is to ensure that the voltage supplied is equal to 0. Only when we short circuit, the voltage supplied becomes 0. And similarly, when we have current sources, we need to ensure that the current that is passed through this circuit is 0. Only when we open circuit this current source, we can say that the current supplied is 0. That is the reason behind short circuiting voltage sources and open circuiting current sources. Now let's have this concept in mind and solve this problem. In this problem, the load's terminals are mentioned to be A and B. So we need to find out the voltage that is across these ends. This is the Thevenin equivalent voltage. This voltage is contributed by the 6 ampere current source and the 16 volt voltage source. So VTH is contributed by the 6 ampere source and then the 16 volt source. Let us first apply superposition theorem and find out the contribution of each of these sources. First, let us consider the 6 ampere source. Since we are considering only the 6 ampere source, we are nullifying the 16 volt source by replacing it with a short circuit, and now we are finding A1 B1, which is the voltage contributed exclusively by this current source. Let us apply source transformation and change this to a voltage branch where we have a voltage source of 6 into 5 which is 30 volt which is connected in series with a 5 ohm resistor. We have this 10 ohm resistor in series and across this we have the terminals A1 and B1. This 10 ohm is in parallel with this 10, so this can be quickly replaced by a resistance. This is 10 ohm in parallel with 10 ohm which is equal to 5 ohm. So therefore the current is circulating through this series path. The voltage across this, which is VA1 B1, is the voltage that is across this 5 ohm resistor. So let's use the voltage division rule in order to find out this voltage. VA1 B1 is given by minus 30 times 5 divided by 20, which is equal to minus 15 divided by 2, which is equal to minus 7.5 volt. Let us have only the 16 volt source and try to nullify the 6 ampere source by replacing it with the open circuit. Now let's call this as the terminals A2 and B2, and the voltage across this can be called as VA2 B2. Now the current that is sent by the 16 volt source, it splits into two branches, one with 10 plus 5 in series and the other one with 10 ohm in series. The voltage across this pair of nodes, which is equal to the voltage across this 10 and the voltage across this 15 ohm resistor. We can simplify this circuit like this. we'll have a 16 volt source in series with this 10 ohm resistor, and now we have a parallel combination of 15 and 10 ohm across the terminals A2 and B2. So this voltage VA2B2 is same as the voltage across the 10 ohm, which is same as the voltage across the 15 ohm. So this 16 volt is shared by the 10 ohm resistor and this 10 ohm in parallel with 15, which is equal to 150 divided by 25, 6 ohm. So this is equal to the voltage across this 6 ohm resistor. So by voltage division rule, this can be calculated as 16 into 6 divided by 16, which is equal to 6 volt. So now the Thevenin voltage contributed by the 6 ampere source was calculated as minus 7.5 volt, and the voltage due to this 16 volt source is calculated to be 6 volt. Therefore, the Thevenin voltage will be minus 7.5 plus 6, which is equal to minus 1.5 volt. So the answer is option A, minus 1.5 volt. Thank you.